Hey math fans, Jason Marshall here with a special look at the solution to Fibonacci's rabbit problem from Math Dude episode 16. Here's Fibonacci's question. If two newborn rabbits are placed in a pen, how many rabbits will the pen contain after 1 year? To answer his question, Fibonacci wanted us to assume that rabbits always produce one male and one female offspring, that they can reproduce once per month, that they can start to reproduce when they are 1 month old, and that rabbits never die. So that's the question. What's the solution? Well, let's think in terms of how many pairs of rabbits are in the pen at the beginning of each month, starting with the one newborn pair in the pen at the beginning of the first month. These newborns are too young to reproduce, so we begin the second month with one pair as well. It's the same pair, but they're now adults that are mature enough to mate. As a result, one new pair of rabbits is born at the end of the second month. So at the beginning of the third month, we have a total of 2 pairs. The original pair again mates at the beginning of that month, but the newborn pair does not. The original pair produces another pair of offspring. So at the beginning of the fourth month, we have a total of 3 pairs of rabbits. The original pair, their newest offspring, and their first pair of offspring, which are now adults. 2 pairs can now mate, and they each produce yet another new pair, giving a total of 5 pairs at the beginning of the 5th month. Now, 3 pairs can mate, so after the 3 new pairs of offspring are born, our total moves to 8 pairs. At this point, the sequence is 1, 1, 2, 3, 5, 8. What's the pattern? The trick is that each number in the Fibonacci sequence is obtained by adding together the previous 2. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8. You can keep going and going on like this to find subsequent numbers, and after 12 months, you'll get 144 pairs of rabbits. In other words, the 12th Fibonacci number is 144. But is that how many pairs the rabbit pen would actually contain after 1 year? No. That's the number of pairs in the pen at the beginning of the 12th month, not the end. So we actually need the number of pairs at the beginning of the 13th month, which is 233 pairs, or 466 rabbits. But how does that compare to the exponential growth of the model where rabbit populations grow like a geometric sequence? The difference is huge. If the rabbit population grew like a geometric sequence and doubled every month, at the end of a year, there'd be 8,192 rabbits. And that's the story of Fibonacci and his rabbits. Until next time, this is Jason Marshall with this week's Math Dude Video Extra. Thanks for watching, math fans.